What is up, weather enthusiasts? I'm your host, Pat's Path Predictor. Let's get right into the weather. Alright, so here's the situation we have for you, ladies and gentlemen. We have a lot of stuff that's going on today. We have a regional situation, a regional severe weather outbreak that is right now underway. So we're going to go ahead and start talking about this real quickly. There are storms firing up in Oklahoma that are going to continue to spread into Arkansas and into parts of the Midwest as well. So we're going to go ahead and dive right into this. Here's what we have from the Storm Prediction Center. We're going to make this very quick for you guys, just so you can understand what's going on. Here's the cliff notes that we have for you right here. We're going to go ahead and move this over right here. We have a 10% hatched risk of severe weather right now for parts of Oklahoma and Arkansas right here. Well, not 10% hatched severe risk, but 10% hatched tornado risk, which means there is a 10% probability of strong tornadoes, which are classified as EF2 to EF5 tornadoes, happening within 25 miles of a point. That's what we have going on right here. We have a 5% tornado risk from Ohio all the way down to Texas, and we have a 2% risk from near Cleveland all the way down to Waco. So that's what we have going on here. The wind risk is the least risk, the lowest risk right here. We have a 15% risk from Ohio all the way down to Dallas, which encompasses Columbus, Indianapolis, St. Louis, Springfield, all those other cities that are going on. But what's also a large risk in this, and what's really driving kind of the bulk of this, is the hail risk. The tornado and the hail risk are the two largest risks with this severe weather event. We have a 30% hatched risk of large hail, potentially large and destructive hail, of 2 inches in diameter or larger, happening within 25 miles of a point from Springfield, Missouri, down to near Wichita Falls, Texas. So that's what we have going on right there. 15% hatched from Indiana all the way to Dallas. So that's what we have going on. Here's a quick summary of what's going on. Large to very large hail, damaging wind gusts, and a few tornadoes are expected for parts of north central Texas into the Midwest and the Mid-South. Greatest overall severe threat still appears to be across eastern Oklahoma and far north Texas into the Ozarks. So that's what we have going on right here across a lot of this area right here. Here's the situation that we have from the NWS. We have tornado watches in effect pretty much from Oklahoma all the way to Illinois over here. That's what we have going on, and it expands all the way to the Illinois-Indiana border right there. And we have several severe thunderstorm and tornado, as well as some flash flood warnings that are in effect for parts of Oklahoma. That is expected to continue to move through parts of Missouri, parts of Illinois, and even into parts of Indiana and Ohio as the day continues to go on. So that's what we have going on. Here's the situation that we have on the ground right here. We're going to pull up some model runs. We're going to pull up the HRRR. We're going to pull up the RAP. We're going to pull up a bunch of other characteristics to kind of map out what we're potentially looking at right here. Here's what we have. We're going to start with the precipitation depiction by the HRRR right here. Here's the situation that we have. This is the 17Z HRRR. Storms are already initiating in parts of Oklahoma right here, but they are expected to grow and continue to expand. And really, it looks like a lot of the discrete stuff is going to be, especially in central Missouri into southern Illinois right there, before it starts to become more linear and before it starts turning into more of a squall line. Which, to be honest with you, the way I'm looking at this now, there's definitely a heightened supercell threat, especially in parts of Arkansas and Oklahoma. But based off of the reflectivity that this is showing, there is a higher supercell threat than I think is given a lot of credit to in like parts of Missouri, around the St. Louis area, into Springfield, Illinois, and into central Indiana right here. I want to go ahead and pull up right here, this supercell composite, to kind of see what we're potentially gauging at. And that kind of checks out what we're looking at. We're looking at a generally higher on average supercell risk, supercell composite risk at least, for parts of Missouri, Illinois, into Indiana right there, with some parts of Indianapolis cracking as high as 10 right there. So we're going to have to pay attention to that as time continues to go on. But in the meantime, if we go ahead and show you the SIG-TOR parameter, SIG-TOR parameter is pretty interesting because right now the SIG-TOR parameter is pretty much the highest over Missouri and Illinois, but it looks like Indiana and Ohio could see even higher SIG-TOR parameter, especially central Indiana right here. We're looking at values as we get into the afternoon, in the evening. This is now 6 o'clock Central Time, 7 o'clock Eastern Time. We're looking at values of almost 7 out of 10 on the SIG-TOR parameter, which is pretty crazy to think about. We're looking at, we saw a 7.4 in Ohio over there. So I'm thinking more there's going to be a higher than expected tornado risk, at least according to the HUR, in parts of Indiana and Ohio. Here's the RAP model to kind of back that up, showing similar situations, although it's more in Illinois and Indiana that we have right here. We're going to go ahead and this is 5 o'clock right here. This is 7.1 out of 10 right here. This is pretty ridiculous. So we're going to pluck a sounding out of this right here to kind of see what's gauging this whole situation that we have going on right here. Okay, this is a PDS tornado sounding right here. That doesn't mean a PDS tornado is going to happen. This is just one sounding out of a plethora of them. I'm just plucking this out because there's a pretty significant SIG-TOR parameter and a pretty big supercell composite. So just bear with me, and we'll continue with this. With that being said, we're looking at shear values of surface to 1 kilometer of 31 knots, which is actually pretty good for some tornado development right there. SRH values of around 200 to 250, which that's pretty indicative of a rather unstable environment. That's a pretty unstable environment. That's a very favorable environment for tornadoes right there. Surface-based CAPE around 2,800 joules per kilogram. Lapse rates around 7.6 degrees Celsius per kilometer, so still conditionally unstable that we have going on. There's not really that much directional shear, which is going to kind of inhibit the possibility of maybe a little bit of supercell firing, but the speed shear definitely does make up to it to some extent right here. We're looking at 61 knots of surface to 6 kilometer going on right there. That's going to help with your supercell development. Essentially, what in layman's terms, speed shear means stronger tornado. Directional shear means more tornadoes. So this could be a situation where the forcing is great enough to cause something like this to happen. So that's what we have going on. And someone in the comments requested I pluck a sounding of Terre Haute, Indiana. This is for 5 p.m. today. So that by the time this comes out, this will be about 2 hours ahead of schedule. So this is, I believe, Vigo County right here. We're going to go ahead and pluck a sounding off of that as well, just to kind of show you to the person who commented what we're potentially looking at. Keep in mind, this is one model, and this is just one sounding that I'm picking out of many, but I am showing you this just to kind of give you an understanding of what we may be looking at. Here's a sounding that we're looking at. Not as much surface to 1 kilometer shear. It was 31 knots in southern Illinois. You're down to about 23. The lapse rate's definitely a bit higher, which could help with some more forcing going on. SRH is definitely lower going into this, so there's not as good as an environment as there is in like southern Illinois, but there is still plenty of surface CAPE, around 2,500 joules per kilogram. That's quite a bit of energy right there. That's more of a elevated to moderate risk of energy right there, not SPC risk, by the way. That doesn't equate to a moderate SPC risk in any means. I'm just saying, like, this is more of an elevated to moderate risk in general for severe thunderstorms. The potential hazard type on this sounding is tornado, but we really have to look at the shear and CAPE profiles to kind of gauge all of that. And we are looking at more of a speed shear setup than a directional shear setup, which is why I can understand why the 10 hatched is not over Indiana and Illinois and over Missouri and Oklahoma and Arkansas. That being said, I want to go ahead and kind of look at the supercell composite down there and kind of get a better gauge of this. Yeah, the supercell composite in southern Illinois is like 12, 13, even 15 in some areas right there. If we go ahead and show you the supercell composite and pluck a sounding, there's definitely more directional shear around Fayetteville, Arkansas. We've been kind of using that as our dropping off point right there. I want to pluck another sounding just to kind of see what we're potentially going to be looking at. Here we go right there. There is more directional shear. There is less speed shear, but the directional does make up for it a little bit. The lapse rate's definitely there, around 8.3. That's going to definitely cause some forcing. Look at this. Surface CAPE of 3,300 joules per kilogram. More than enough energy to cause a situation where we have some severe thunderstorms and maybe a tornado or two for your area over there. That's what we have going on with the RAP. We're going to go ahead and show you this kind of the convection that we're looking at right here. We're looking at the simulated reflectivity with this. The RAP isn't particularly great with simulated reflectivity so we'll go ahead and go back to the HUR. We'll go back to the 17Z since that's the furthest it goes. Yeah, we're looking at more of a potential like squall line setup down in Arkansas, although there are some supercells that could end up organizing and developing down there. As you can see right there, especially Dallas Fort Worth, you could see some organized supercells potentially organize and fire up, particularly in the DFW area. So if you're tuning in from down there, be sure to pay attention to that going on right there. But this does look like a more of a squall line setup going into the evening and into the overnight into Arkansas, Louisiana, Mississippi, Alabama. Right there, we can go ahead and kind of show you what we're looking at for day 2 right now. There is actually a slight risk, interestingly enough, for parts of Texas right there, for parts of San Antonio and Austin, although there is a very large marginal risk from the U.S.-Mexico border all the way to North Carolina around the Charlotte area. So I just thought I'd show that to you guys just to get a better understanding of what we're kind of looking at this current point in time. So yeah, that's the situation we have going on with her right there. That's the situation that we have going on. I want to go ahead and take a look at some other models as well, just to kind of gauge at potentially the environment right here. Here's the surface-based CAPE that we have right here. The CAPE is cracking 4,000 joules per kilogram in parts of Kansas, Oklahoma, and even into Missouri a little bit. It's expected to remain 3,000 to 4,000 for a lot of the area before a cold front starts pushing it through. What is kind of going to be helping this forcing, we're looking at a warm front setup right here and a cold front setup down there, and that cold front is going to bring some cooler temperatures to a lot of the region right there. Now, one last thing I want to take a look at is kind of the moisture component as well as the temperature. Let's look at the dew point that we have going on right here. The dew points that we have, this is for 4 p.m. Arkansas is almost cracking 70, ladies and gentlemen. That's a very moist environment right there. Across Missouri and southern Illinois, we're looking at lower to mid-60s right there, although we have seen some upper 60s in isolation right there for parts of the dew point, which is more than enough for really some forcing and some organized thunderstorms to happen. And this is what we have going on. Here's the temperature that we have before all this big stuff starts up. We're looking at upper 70s, lower 80s in parts of southern Illinois, although we get to the lower 80s in parts of southern Missouri, especially around Springfield, Branson, those areas right there. And then to Arkansas, mid 70s to lower 80s right there, that general range. And if we go ahead and show you the relative humidity, it's a rather moist environment for thunderstorms to take a look at. So we're going to have to pay attention to this. The vorticity on this is going to be pretty interesting to take a look at. The vorticity on this is kind of strong with this, although it's not as strong as I've seen with other model runs. But we're still looking at a potentially big threat for some temperatures and for some severe weather to happen over the next few days or so. So we're going to keep you updated here on the Pat's Path Predictor channel. But with that being said, ladies and gentlemen, we're closing the video out right here. I really hope you enjoyed it. Be sure to leave a like and subscribe to the channel if you are new. It helps us out, helps us make more videos like these. The goal of this channel, as always, is to get more people engaged with weather. And be sure to follow my Twitter for more stuff I'm going to be firing out with soundings, with some severe thunderstorm warnings, all that kind of stuff. So be sure you keep an eye out for that. But with that being said, have a wonderful day, guys. Stay safe.